Hey everyone, welcome back to Learn Splunk Easy. Today, we're going to talk about something every Splunk admin does: installing Splunk on Linux. Now here's something interesting. When you install Splunk using a tar file, you do everything manually. But when you use DEB or RPM, suddenly everything feels automatic. Splunk user? Created. Splunk group? Created. Set ownership and permissions? Done. So the real question is, who is actually doing all this work behind the scenes? Let's break it down. Simple, clear, and easy. Now let's see the 3 installation methods of Splunk on Linux. On Linux, Splunk can be installed in 3 ways. Method 1, tar file. Tar files work on any Linux. You can use them if your OS doesn't support DB or RPM, or if you want full manual control over installation paths and users. Method 2, DB package. DEB packages are designed for Debian-based systems, like Ubuntu or Debian itself. They integrate nicely with apt and systemd. Method 3, RPM package. RPM packages are for Red Hat-based systems like RHEL, CentOS, Fedora, or Rocky Linux. They integrate with Yum or DNF and systemd. Important thing to remember: Splunk software is the same. The installation method is different, depending on your Linux OS. Now let's start with tar installation. A tar file is just a compressed archive. It contains Splunk binaries, configuration files, libraries, and that's it. You can install or extract the .tgz package using the following command. When you run this command, Linux does only one thing. It extracts files into /opt/splunk. Now let's see this in action. Now I am in backend of my server. This is a fresh server and Splunk is not installed. I have already downloaded the latest version of Splunk TGZ package from Splunk website. Let's extract the package using the tar command into /opt directory, and this will take few seconds to complete. The extraction is completed. Now let's verify the Splunk. I have long listed the files in the Splunk directory. Here you can see the list of files present in the directory and can see the 10777 ID for user and group of each file and directory. That is because the Splunk user and Splunk group are not present. Because of this, it's just showing IDs. So with tar installation, Linux does none of the system-level work for you. It does not create the Splunk user. It does not create the Splunk group. It does not set file permissions. It does not create a systemd service. And it does not enable boot start. All Linux does is extract the files. Everything else is your responsibility. And that's exactly why tar installation feels manual. Now let's talk about DEB and RPM packages. Let's understand what a .deb file really is. A .deb file is a software package used in Debian-based Linux systems, like Debian, Ubuntu, and Linux Mint. But here's the important part. A .deb file is not just the software itself. Inside a .deb file, you'll find 2 things. First, the actual software files, the program you want to install. And second, rules and scripts that tell Linux how to install, configure, start, and even remove that software properly. So instead of just copying files, Linux follows clear instructions during installation. That's why we can describe a .deb file like this: software plus installation instructions. And that's what makes .deb packages smart, reliable, and easy to manage on Linux. Now let's see the file structure of a .deb file. Internally, every .deb package contains 3 important parts. First one is Debian binary. The very first file inside every .deb package is called Debian binary. This is a very small text file. Most of the time, it contains just one line, 2.0. This number tells Linux which DB package format version is being used. Before installing anything, dpkg reads this file and checks compatibility. Next comes control.tar.xc. Inside this archive, you'll usually find these files. Control. First is the control file. It contains the package name, version, architecture, and most importantly, dependencies. Preinst. The preinst script runs before installation begins. Postinst. The postinst script runs after installation completes. This is where users are created, permissions are set, services are started, and boot start is enabled. Perm. The perm script runs before the package is removed. Postrum. The postrum script runs after the package is removed. Confiles. And confiles tells Linux which configuration files should not be deleted automatically. Finally, we have data.tir.xc. This archive contains the actual software files. Inside data.tir.xc, you'll see real Linux directories like /usr/bin, /usr/lib, /etc, /var. Now let's see how to extract the Splunk.deb package and explore the content inside it. Currently, I have Splunk 9.4.7 deb package in my environment. Let's extract the files from it. For extracting the files from the .deb package, we can run AR command with X argument and package name passed to it. This will extract all the files in the package. As discussed before, we got three main files: control.tir.xc, data.tir.xc, and Debian binary. Now let's create two directories, control_files and data_files. In control_files, we will save the files from the control.tir.xc, and in data_files, we will save the files from data.tir.xc. So we have new directories ready. Let's untar the control and data file to their respective directories. We will use command tar-xvf package, name -C destination directory. This will move the extracted files to the respective directories. Now let's see the content inside each file and understand exactly how the Splunk user, group and file permissions are automatically created when installing the Splunk using .deb package. For better understanding, let's open this directory in Visual Studio Code. Now let's concentrate on the main files. The very first one, Debian binary, as discussed previously, this file just contains version. The next one is control_files. This is the directory where we placed all our files from control package. The last one is the data_files, where we place the files from data package. This contains the entire files related to the Splunk Enterprise package. So now let's discuss how this works. Whenever we install Splunk using .deb package, it will first run the print script. This script will do steps like setting up environment variables, creating user, creating group, etc. We will discuss this in deep later. Next, it will extract the package to /opt directory from the data package, and then it will run the post-inst script, where it will set the permissions, etc. The script starts with bash and sets a safe system path. Then it defines two important variables, product and component. These help Splunk decide whether this is a Splunk Enterprise or a Splunk Universal Forwarder. This one script is used in both Splunk Enterprise and Splunk Universal Forwarder installation. From line 26 to 43. This block is used internally by Splunk. It validates an embedded binary inside the installer. Normal users will never trigger this. Think of it as installer self-checking. If validation fails, installation stops. From line 45 to 54, this block checked the following. Before touching the system, the script checks if required Linux commands exist. Commands like useradd, groupadd, id, grep. If any command is missing, the installer stops immediately. This prevents broken installations. From line 56 to 77, this block checks which operating system Splunk is being installed on. If the system is Linux, Splunk is installed under /opt/Splunk by default. In RPM installs, if a custom install path is provided, Splunk uses that location instead. If the system is Darwin, which means Mac OS, the installer uses the path passed by the installer and sets Splunk home accordingly. So this code simply does one job: detect the OS and decide where Splunk should be installed. From line 81 to 101, this part is very important. The installer first checks, is Splunk already installed or not? If the Splunk binary exists inside Splunk_home, Linux understands this is an upgrade, not a fresh install. In case of a Splunk Enterprise upgrade, the installer runs an internal pre-install check. This check makes sure the existing Splunk setup is healthy and safe to upgrade. If the check fails, the installation stops right here. And that's a good thing, because Splunk never upgrades a broken system. For fresh installs or other components, this step is simply skipped. From line 103 to 236. Now this block handles user and group creation. First, the installer checks which operating system it is running on. Let's focus on Linux first. If this is a Splunk forwarder, the installer looks for a Splunk viewed user and group. If this is Splunk Enterprise, it looks for a Splunk user and group. Before creating anything, it carefully checks. Does the user already exist? Does the group already exist? If they exist, Splunk does nothing. If they don't exist, Splunk creates them automatically. During a forwarder migration, Splunk even tries to reuse the previous user and group instead of creating new ones. For macOS, this step is skipped. For Solaris and BSD systems, the same logic applies, but with OS-specific user and group commands. The key idea is simple. DEB and RPM installers automatically handle users and groups for you. That's why you never create them manually. From line 238 to 244. This small but important block checks if Splunk is already installed. If it finds an existing installation, it safely stops the running Splunk server before continuing. This ensures that the upgrade or installation won't run into conflicts with an active instance. And notice, if Splunk isn't running, the script doesn't treat it as an error. It just quietly continues. Finally, the script ends gracefully with an exit code of 0. And that's basically how the pre-installation script works to prepare your system before Splunk gets installed or upgraded. Now, previously we saw the pre-install script. It handled user creation, OS detection, and pre-install checks. Now, let's dive into the post-install script to see how Splunk configures itself after installation and sets up permissions, messaging, and even desktop icons. From line 1 to line 19. In this block, we set up the environment for the script. We define the product, component type, system variables, and architecture. We also create a default URL message for Splunk Web, which we skip if the package is a forwarder. Finally, we initialize an upgrade flag to track whether this is a fresh install or an upgrade. From line 23 to 39. These functions help detect the currently installed Splunk version and build. This is crucial for upgrade scenarios, as the script needs to know if it's replacing an older version. If the version file is missing or unreadable, it prints an error. From line 41 to 73. This function is the heart of post-install cleanup. It fixes file and folder ownership under Splunk_home, depending on whether this is a forwarder or a full server. It even ensures Python site packages are writable, preventing permission errors when Splunk runs. Basically, it guarantees your installation has the correct permissions for smooth operation. From line 75 to 102. The script checks if the Splunk user or forwarder user already exists on the system. It uses the ID command on Linux, SunOS, and BSD, and falls back to /etc/password for other systems. This ensures that the post-install process respects existing users and avoids conflicts. From line 104 to 164. This block sets the Splunk_home path based on the operating system and installation type. It also detects whether this is an upgrade or a fresh install by comparing installed versions. On macOS, it also sets the path for the GUI launcher resource. This ensures the rest of the script can safely work with the correct installation directory. From line 166 to 172. The script generates Splunk launch.conf from the default template if it doesn't exist, setting the correct Splunk_home. It also creates a temporary FTR file and records the package type, which is useful for tracking how Splunk was installed. From line 178 to 214. This block creates user-friendly post-install messages. It prints whether Splunk was installed or upgraded, provides the URL for Splunk Web, and shows how to start the server. For macOS, it adds instructions for the desktop icon. Everything is written to the FTR file, so users see clear guidance after installation. From line 217 to the end. The final block, we apply the fix_splunk_home_permissions function to ensure ownership and write permissions are correct. On macOS, the script creates a desktop alias for Splunk and opens the app automatically. Finally, it touches a file to indicate completion and exits cleanly. And that's how the post-install script ensures Splunk is ready to run right after installation. So that's how the Splunk.deb package works under the hood. The pre-install script prepares your system, checks users and permissions, and even handles upgrades. Then the post-install script sets everything up, fixes permissions, and gives you helpful messages to get started. And just like that, Splunk is ready to run on your system, safe, clean, and fully configured. Let's understand what an .rpm file really is. An .rpm file is a software package used in Red Hat-based Linux systems, like RHEL, CentOS, Fedora, and Rocky Linux. But here's the important part. An .rpm file is not just the software itself. Inside an .rpm file, you'll find two main things. First, the actual software files, the program you want to install. And second, metadata and scripts that tell Linux how to install, configure, start, and even remove that software properly. These scripts can run before installation, after installation, before uninstall, and after uninstall, making sure everything is set up correctly. So instead of just copying files, Linux follows clear instructions during installation. That's why we can describe an .rpm file like this. Software plus installation instructions. And that's what makes .rpm packages smart, reliable, and easy to manage on Red Hat-based Linux systems. Now let's clearly understand what an RPM package actually looks like internally. An RPM file is not just a compressed archive of software files. It's a structured container designed to manage installation, verification, and removal in a controlled way. At the top, we have the RPM package itself. Inside this package, there are three major components. First is the GPG signature. This part is responsible for security. Before installing a package, the RPM system checks this signature to make sure the package comes from a trusted source and that it hasn't been modified. If the signature verification fails, the installation can be blocked. So this step ensures integrity and authenticity. Next comes the header, also known as metadata. This is a very important part, but it often causes confusion. The header does not contain the actual files. Instead, it contains instructions and information. This includes the package name and version, dependency details, file paths, ownership and permissions, and also the installation scripts like pre-install, post-install, pre-uninstall, and post-uninstall scripts. Think of the header as a blueprint. It tells the RPM system what needs to happen, in what order, and where files should go, but it does not carry the file data itself. Finally, we have the payload. This is a compressed CAIO archive, and this is where the real content lives. The payload contains the actual binaries, configuration files, libraries, and other resources that get installed onto the system. During installation, RPM first reads the header to understand dependencies and instructions, then runs the pre-install scripts, extracts the payload files into their target locations, and finally runs the post-install scripts. So the key idea to remember is this. The header controls the installation logic, and the payload delivers the actual software. Once you understand this separation, RPM packages become much easier to analyze, troubleshoot, and compare with other package formats like DB. Now that we understand the internal structure of an RPM package, let's see how we can extract and inspect its contents on a Linux system. The first and most important thing to remember is this. Not everything inside an RPM is stored as normal files. Only the payload contains actual files that can be extracted. The header and GPG signature are metadata, so they are inspected, not unpacked. Let's start with the payload, which contains the real files like binaries, configuration files, and libraries. To extract these files without installing the package, we use a combination of two commands. First, we use rpm-to-CAIO to convert the RPM package into a CAIO archive. Then, we use CAIO to extract the files. When we run this command, all the files inside the payload are extracted into the current directory, preserving their original folder structure. If you only want to see what files the RPM would install, without extracting anything, you can list them using the rpm query command. This reads information from the header and shows the file paths. Next, let's talk about installation scripts like pre-install and post-install scripts. These scripts are not part of the payload, so they cannot be extracted using RPM 2.pio. Instead, they live inside the RPM header. To view or save these scripts, we query the RPM metadata and redirect the output into files. This allows us to analyze the scripts safely, without installing the package. Now, what about the GPG signature? The signature is used only for verification. It ensures the package is trusted and hasn't been tampered with. This part cannot be extracted as a file. It can only be checked using the RPM verification command. So to summarize, the payload can be extracted, the scripts can be dumped from metadata, and the signature can only be verified. Understanding these extraction methods is extremely useful when debugging installations, reviewing third-party packages, or learning how RPM works internally. Now that we've extracted the RPM scripts, let's open them in VS Code and understand what each one does. Inside an RPM package, you'll usually see three important scripts: pre-install, post-install, and post-uninstall. Let's start with the pre-install script. This script runs before any files from the payload are extracted. It's typically used to prepare the system, things like checking system conditions, creating users or groups, or cleaning up old settings. Next is the post-install script. This runs after the payload files are installed on the system. Here you'll often see tasks like setting permissions, enabling services, starting daemons, or performing final configuration steps. If this sounds familiar, that's because these two scripts are very similar to what we saw earlier in DEB packages. RPM pre-install is similar to DEB's pre-inst script, and RPM post-install matches DEB's post-inst script. Now comes the interesting part, the post-uninstall script. This script runs after the package is removed from the system, and it's mainly used for safe cleanup tasks. In this case, the script does not remove users or core data. Instead, it focuses on cleaning up runtime-generated files, like Python cache files, and removing specific module files only during a full uninstall. It also includes safety checks to make sure that no files are deleted during an upgrade, which helps prevent accidental data loss. This is something that does not exist in the same way in DEB packages, which makes it unique to RPM-based systems. So to summarize, pre-install prepares the system, post-install finalizes the setup, and post-uninstall handles cleanup after removal. So we've come to the end of this video, and I'd like to conclude with the following. This video is purely for understanding and learning purposes. There is no single best way to install Splunk. Each installation method, tar, DB, or RPM, exists for a reason, and the right choice depends on your environment, your requirements, and your use case. The goal of this video is to help you understand what happens behind the scenes, so you can make an informed decision. Thanks for watching. Keep learning, stay curious, and make Splunk easy with us. Don't forget to like and follow, and connect to stay updated with our tutorials. Check out more content from Learn Splunk Easy to deepen your Splunk skills and master it step by step.